Hey everyone, author Jonathan David here. So I'm going to share my screen with you so you can see the solution to this question. And so consider the system of linear equations. You got a three system of equations here, x, y, and z, la da 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 da. And you want to solve for the values of k such that k is a real number so that you have, let's see, unique, infinite, many solutions, da da da. So, or you could say inconsistent or consistent solutions. And anyways, fix that there. This board's a little goofy. In fact, let me just go back to the document here. And let me pull up my camera so you all can see me. All right. So first, put it in an augmented matrix, right? Like so. It's actually a very simple question. Once you have a few basic knowledges of things, you're just going to do. There's different ways to do these depending on which section of the book you're in. You could do determinants and things, but I'm assuming it's just row reduction at this point. So you get it in an augmented matrix. Then what you want to do is get it into a lower triangle. You see the 0, 0, 0 right here? I got a lower triangle of zeros. Once you do that, it's a walk in the park. So what I did is I added row 1 to row 2 to make a new row 2. And then I added -2 times row 1 plus row 3 because you see 1 and 2. What do I multiply 1 by to get rid of this 2? -2 plus positive 2 is 0, right? So you start at the first column, kick off elements consecutively, one by one in order. Then you go to the next column and you drop one and kick them off. So I killed this one, and then this one to get my lower triangle. So you just got to go down the columns at an angle one by one to get it in that lower triangle. Then once you have it in the lower triangle, you'll see here if you have 0 equals 0 in the bottom right, you have infinite. If you have 1 equals 0, it's unique. If you have 0 equals 1, then you have, I don't know why that's cutting off right there. That's weird. If you have 0 equals 1, you have no solutions, okay? So once you get there, all you do is you set k plus 6 equal to 1. And so let me do that. k plus 6 equals to 1, right? So what satisfies all of that? So for these cases here, if it's infinite solutions, then we need to have 1 is equal to 1, because then you have 1 minus 1 is 0, 0. So when k is equal to -5, you have infinite solutions. And then for a unique solution, k can be anything except for -5 and -6. K cannot equal, what's that? Not equal. No, it was equal that. Why are you doing this to me? Hey, okay, let me just. There's something wrong with this thing right now. K is not equal to -5 or -6, because over here, if k is equal to -6, we get 0 equals 1. And you can see that right here, -6, 0 is 1, that's no solution. If it's -5, you get 1 equals 1, you get infinite solutions. And so a unique solution is all values when k is not equal to why are you doing that to me? Not equal to -5 or 6. So having a little glitch in my LaTeX here. Anyways, it's not a difficult problem. That's all you have to do. And if you're looking for a linear algebra tutor, check me out at wyzant.com/tutors/JJ the tutor, or you can check out my YouTube channel /codinghumans. Check out my fiction stories, or I've got some 5,000 to 10,000 math and physics lessons that you can watch for free. Thanks.